Plant room is located in the basement and requires a double height due to the size of equipment and its operations. It houses the chillers and the various pumps for HVAC. It also houses boilers for winter heating and humidity control. HVAC plant room of a large hospital is a major source of electrical consumption, and it may even consume up to 60% of the total electrical load. Therefore, it is advisable to provide a dedicated HVAC electrical panel, and it is preferable for the HVAC plant room and the electrical rooms to be as near as possible. Now, in a hospital, we have many special types of areas, and we will discuss them one by one. The first very important area is emergency. Emergency has to be the most easily accessible area for someone coming from outside. It should have some space for parking of ambulances and visitor vehicles. Emergency is provided with a separate flow mounted AHU with a pre-filter and fine filter, and the air is also treated with UV light. As with all critical departments, we provide an individual electrical panel and UPS. It is provided with hot and cold water supply also. Now we come to the operation theatres. For the operation theatres in the hospital, there would be special requirements of drainage. A separate ETP drainage line is provided for the operation theatres. If the OT is in the basement, it would have its own sump and pumps also, one pump working and one standby. One dedicated autoclave unit is provided for the disinfection of laundry from the OTs only. Each OT has a dedicated UPS which is connected to a centralized UPS. Operation theatres are usually planned as a set of OTs near each other. There may be 2 to 10 OTs in a set. OTs have 3 levels of barriers. As you can see in the sketch below, the dirty corridor, then they come the services, then the clean corridor, and then the operation theatres. The operation theatre doors are hermetically sealed to prevent anything from entering. Every surface in the OT is washable, and there are no sharp edges in the civil work, and they have to be rounded off for the purpose of cleaning. Each OT has a dedicated AHU fitted with pre-filter and fine filters, humidifiers, smoke extraction fan, and UV chamber. A good HVAC solution can be to provide a laminar flow plenum in the OT fitted with a HEPA filter in the center of the OT suspended from the ceiling slab above the false ceiling to give in the conditioned air. The return air may be collected from all the 4 corners, raised 450 mm above the floor. The next area to be discussed is the critical care and intensive care units. The most critical areas in a hospital are OTs and the critical care units like the ICU, ICCU, PICU, NICU, etc. One AHU fitted with pre-filter and fine filter and designed for smoke ventilation is provided for each unit. Each CCU has an isolation room. The HVAC system for the isolation rooms is to be so designed that conditioned air is only supplied there and no return is taken from there. Air is fully exhausted out, preferably at terrace level. For reasons of public health and hygiene, the air should be exhausted after passing through a HEPA filter. As all other critical areas, each CCU is to have its individual UPS which is connected to the main UPS. Contamination is a major concern in all critical areas. We use the technique of differential air pressure. In all such areas, we keep the pressure higher than the surrounding areas and corridors so that no air and therefore no infections come into them through the door openings, etc. Fire safety of patients on life support is quite critical, and it has been discussed in the fire safety section. Smoke extraction and exhaust system in HVAC. Where critical patients are there, the air is treated with UV rays in the AHU for purification. In the hospitals, you also have LINAC rooms, which are linear accelerator rooms. Now, the linear accelerator rooms may be there in the basement. This is a part of oncology, where external beam radiation treatment is given to cancer patients. Obviously, this is an extremely sensitive zone and it needs to be made radiation proof. And that is done by using thick RCC walls, maybe around 1100 to 1200 mm thick. Sort of like in a nuclear bunker. LINAC room will have its own separate ETP line for discharge of effluent along with its sump and pump. Now in this drawing we can see that at places, the LINAC room's walls even extend up to 2400 thick. The next department that we discuss is radiology. The radiology department is most often located on the ground floor for sake of easy access. It's a critical area as it houses very heavy and very sensitive equipment. Equipment for testing like X-rays, MRI scans, CT scans, ultrasound, etc. It has a separate floor mounted AHU as the area is quite big, which is fitted with filters like pre-filter and fine filter. The air has particulate matter, pollutants, chemicals, bacteria, germs. The radiology equipment is extremely sensitive and needs to be protected. So we ensure that nothing enters from outside directly. The radiology department is also a major consumer of electricity. So we provide for a separate electrical floor panel for it and its own UPS. The MRI or the magnetic resonance imaging scan is based on magnetic resonance and the room has a magnetic field. We have to avoid metal ducting and all other metal parts. The MRI equipment specifications will specify the minimum distance at which the metal ducts can be placed. In this room, smoke ventilation and extraction is not really required in the HVAC. Now we come to the outpatient departments or OPDs. As soon as we enter the hospital, there would be an atrium area or a large entrance lobby, and quite nearby we will have the outpatient departments. These areas have a large number of people visiting and waiting and are critical due to the high population. It's important to have a proper system of smoke extraction and fresh air supply in these areas. In small hospitals, it is possible to have a ductless systems of ventilation, but in case of large areas or high occupancy, it is important to have a ducted system of smoke extraction and for the windows to open automatically so that fresh air may enter as smoke is being exhausted. OPDs are often placed on the ground floor, but depending on the numbers can be distributed on any other floor too. Consultation room, if they are large for OPDs, can be air conditioned with individual FCUs suspended from the ceiling. If the number of rooms in one area is quite large, it is more efficient to use one floor mounted AHU for all of them and then provide conditioned air through individual VAVs, which are variable air valves. Some outpatient consultation rooms have particular requirements also, which have to be serviced. For example, a dental consultation room will require water supply and drainage. A cardiac consultant will require specific requirements for electrical power. Now we come to individual rooms and wards. For the inpatients, there are rooms and wards. Rooms may be single or double occupancy. Rooms with the 4 patients or more are treated as wards for the purpose of services design. In individual rooms, conditioned air may be supplied through fan coil units or FCUs suspended for the ceiling in the corridor just outside the room. The supply grill is in the room and the return air is taken from just under the FCU in the corridor. The wards are provided with a small ceiling suspended AHU in a corner for the ease of maintenance. Air distribution through the ward is done through diffusers. Each room will have a thermostat for temperature control as per the individual requirement. One possible layout is shown in the drawing where we see the location of the FCU in the corridor outside the room next to the toilet. Room toilet